Okay, so this example wants us to use 2D grids to calculate some probabilities involving two independent events happening. So we've got flipping of a coin and then spinning this spinner with three possible outcomes of A, B, or C. So on our two-dimensional grid that I've drawn down here, on one axis you have the first event, which is flipping the coin, which will result in a heads or a tails. And then on the other axis, you'd have A, B, or C, which is the possible outcomes of the second event. Doesn't matter what axis you put which event on, it's going to come out with the exact same answers anyway. So looking at this, each little intersection point represents a certain outcome. So that one there represents flipping a head, then spinning an A, and then this one is flipping heads and then spinning B. So each of these points here represent a certain outcome. It's really quick to see that we've got 6 possible outcomes from these two events happening. This is quite a simple one, but when we have lots of different outcomes from different events, 2D grids can be really handy in visualizing what's going on and how many outcomes there would be. Instead of having to go and list the sample space by going HA, HB, HC, etc., especially when we have more possible outcomes. So already I know from this grid we have 6 possible outcomes there. So now we can answer these questions here. Find the probability of flipping a head and spinning an A. So that's this represented by this point here. So one of the options satisfy that question. So 1 out of the total 6 is the probability of heads, and A is equal to 1 over 6. Now this second one here I'll do in a different colour. The probability of getting a B on the spinner. So this isn't indicating at all whether we're flipping a heads or tails. So these ones here are our two outcomes which have the result of getting a B on that spinner. So 2 out of the possible 6 outcomes, probability of spinning a B is going to be 2 over 6, which can be simplified to 1 over 3.